Chapter 9 Fluid Mechanics. Starring
James Chen.
and Corey Smith. Laminar and turbulent flow.
Laminar flow is when the current of the water is smooth and every particle follows the same path.
As demonstrated by the two boats, they are following the same path. They do not deviate from the path that they are taking. Here, the river goes from laminar flow to a turbulent flow, and will be shown when the boats take a different path when they go over the small falls. Turbulent flow is demonstrated here as the paper boat is going through a bunch of eddy currents in the water, which are chops in the water. So, laminar flow is when the water is smooth, every particle follows the same path, and turbulent flow is when the water movement is irregular, and there are obstacles in the water. The pressure pipe.
Fluid pressure is experienced in any type of fluid. The deeper in the fluid an object is, that object experiences more pressure.
Fluid pressure is shown here as on the pipe, the deeper down the hole is, the longer the water has a straight path. So the closer the water is to the ground has the deeper pressure, and the ones that are closer to the top of the pipe have a lighter pressure. Pressure can be experienced in any fluid, and the deeper in the fluid, the more pressure is experienced, as shown with the pressure pipe.
According to the ideal gas law, PV equals NkGT, where P is pressure, V is volume, N is the number of particles, kg is a constant, and T is temperature.
As shown with the soda can, before the experiment, the soda can was heated, increasing the temperature. When the heated can was put in the ice water, temperature decreased, causing pressure and volume to also decrease.
This demonstration shows Archimedes' principle. The rock displaces water in the container equal to the volume of the rock.
The water taken from the cup shows the volume of the rock. Archimedes' principle was discovered when the Greek mathematician Archimedes was taking a bath and dropped a golden crown into the tub, and the displaced water made him realize how different densities cause different volume.
Buoyancy is an upward force that is experienced when submerged in any type of liquid.
In a fluid, buoyancy is the opposite force to gravity, which causes the object to stay afloat in equilibrium, based on the density of the object. Buoyancy was shown in this demonstration as the empty bottle was air, would float, the partially filled bottle would stay partially submerged, and the filled bottle sunk due to having equal density with the water.
As shown, Pascal's principle states that when a fluid is in an enclosed container, any force acted on the fluid is equally distributed in the fluid and on the walls of the container.
As stated by Pascal's principle, the force of the wooden plank on the top of the beer bottle caused the pressure to be multiplied and evenly distributed to the other parts of the container, causing the bottom to fall out.
Bernoulli's principle is what allows lift. According to it, pressure in a fluid decreases as the fluid's velocity increases.
Due to the flow of the air, only one ball can stay afloat at a time. Bernoulli's principle also allows the ball to stay afloat in the air despite the angle of the hairdryer, as this diagram shows is the air currents. So with the ping pong ball, the velocity of the air on the sides of the ping pong ball increase, causing the force of gravity and the force of the air pressure to keep it afloat. So what have we learned?
Fluid flow and laminar flow, objects flow smoothly.
Fluid flow. In turbulent flow, objects flow irregularly.
Fluid pressure, there is more pressure at the bottom of a pillar of water.
Or any other form of fluid. Ideal gas law. When temperature decreases, so does pressure and volume.
Archimedes' principle, volume of displaced water is equal to volume of inserted object.
Buoyancy. When submerged in water, different densities and forces float differently.
Pascal's principle, pressure applied to a fluid in enclosed container is transmitted equally to every point of the fluid.
Bernoulli's principle, the pressure in a fluid decreases as velocity increases. And that is fluid mechanics.
by James Chen and Corey Smith.